Let me share my screen. Yeah. Are we done with KNN? We are in la. Oh, okay. Okay. I will, very good. I will close that one. And let me check what is the next topic. Elbow method technique I need to close. Okay. K means we done. The next one will be, let's move on with hyperparameter tuning technique. Spare some time. Head to cover, right? Talk with me. Confusion matrix, head to cover. We are not at cover. But above all topics, we done. Head to cover. Noted done. Okay. We are, let me start today hyperparameter tuning technique. One 104. K means clustering. This is something like a, we'll close this one in another few minutes. I'm sorry, please wait for a few minutes. This is continuation, and the next topic will be grid search CV. That's okay. Team, I'm pretty sure I hope you understand k-means clustering algorithm. What algorithm? K-means clustering algorithm. So make a note on this one. The major part will be how to identify number of clusters. How to identify number of clusters. If you wanted to understand, there are two ways. The first one, visualize. By using visualization, we can understand. The second point will be backend machine learning algorithm will apply elbow method technique. What technique? Elbow method technique. And let me show you how it is working in the backend actually. And let me open the material. K-means clustering. Now elbow method technique actually. Get ready to understand. This example we done. So if you want, I can just have to go back here. These are all we done, sir. These are all we done. Now understand this one. Elbow method technique. We are going to draw this kind of diagram. From this diagram, you will get a very clear. There is one edge point. If you keep your hand like this, actually, I'm sure I can say this one is a elbow symbol. What symbol, sir? Exactly, it is giving symbol for where actually? Can you tell me? 3. Then I'm sure. How many clusters we have taken? 3. That is a valid value. That is a right value. That is what exactly mean? Right value. Come on, let me draw this diagram. You will get an idea. First, what we need to do, elbow method technique. Importing the libraries as usual. We just need to import the libraries. Step number 1, importing the libraries. Step number 2, loading the dataset. Step number 2 is what exactly, sir? Loading the dataset. Load the dataset. We already know these are all. Step number 3, do the data preparation. I'm sure you already know when it comes to data preparation, apply min-max scaling on age and income. It should be the first. Team, we done these are all in the last week. If you really understand the session, we done actually. Now, wait some point here actually. Can you tell me what is this one? What do you mean by SS? Go back. Sum of squared error. If you go back to the elbow method technique and here, what exactly we are planning will be, yeah, this we are going to calculate. Sum of squared errors. What is the topic name? Daniel, what do you mean by that? Imagine this is the centroid. From this centroid, we just need to calculate the distance from every point actually. The distance from every point to centroid. All the distance we need to store in one list. We need to store in one list. Yeah. Then we are creating empty list. Make a note on this one. Good. The next point would be what exactly I'm doing, sir. I'm just trying to creating, yeah, range. What do you mean by K here actually? Cluster. So range, let us just have to take 1 to 10. 1 to what exactly, sir? 10 values actually. Now, make a note on this one. For every cluster, for K in K range actually. Chapman sir, K. What is a K? Cluster. I mean to say for first cluster, we are plotting. Second cluster, we are plotting. Third cluster, we are plotting automatically. Now, Tim, can I ask a question? Previously, did you remember here the value what I done, sir? I have hard coded the value. What value? 3. Instead of hard coding, we are taking dynamically, we are trying to saving that value in list. Let me show you how to do that actually. And there is a method name is so called as a fit. I hope you already know this. You created a cluster, right? Apply that cluster over the data. This is the way we can apply actually. The next point will be ssc.append. Any idea what is this one? In inertia. What is that, sir? Special attribute. By using that one, we can find out the error. Some of the squared error actually. Some of the what exactly mean? Squared error. And now you can just try to store that SSC error in especially empty list actually. Then we are using append method. Good. I hope the values are being getting ready. Yeah, Daniel. Now it's the right time. We need to plot. If you closely observe the diagram, on x-axis what I'm taking, sir? I am sorry. On x-axis what I'm taking k value, and y value what I'm taking SSC value. Please observe this. On x label we are taking cluster, either first cluster, second cluster, third cluster. Y axis I'm taking some of the squared error actually. Now plt dot plot of x range. The next one will be SSC value. Let's apply this. Data set is missing. What is missing, sir? Data set. Income, you can just try to pull that. Please understand this. No doubt in that. Can I say? Can I say this one is the edge point actually? Yes. Then how many clusters who can confirm? 3 clusters actually. Did I hard code it anywhere else as a 3? Now the data is telling go with the 3 clusters. Go with what exactly, man? 3 clusters actually. Daniel, do we need to write this one explicitly? We are not writing in real time, sir. But if you wanted to know how to decide number of clusters actually, use this technique. Use this technique. Visualization. Make a note on this. And apply this technique also. If you wanted to know, apply this technique also. That's what you need to be understand, sir. We done that. Now the next topic would be why? Because by looking at the diagram, we can tell automatically. I'm sorry. By looking at the diagram, edge point we can tell automatically. Okay. This is really again the quite interesting example. The topic name is called as a hyperparameter tuning technique. What is the topic name? Hyperparameter tuning technique actually. Only my voice is clear, right? Before proceeding, can I check with you? My voice is clear, I guess. Why do we need to store actually? We are using that one, sir. The stored data we are using later actually. Okay. Yeah, we can print. We can print and we can say. We can say. How many values it is being getting storing. We can say. Okay. Let's just try to open the material. Okay. Come and read one more time. What is the topic name? Hyperparameter tuning technique. One of the technique name is called as a grid search CV. What is the technique name? Yeah, good. Daniel, simple how to improve model performance. How to improve what exactly? Model performance. Model what exactly, sir? Performance. We already know. The first one is called as a splitting the data. So what is the first one? Train underscore, test underscore, split. This is the one way. Splitting the data. The second one would be k-fold cross validation. Careful cross validation. I'm sorry. Third technique is called as a hyperparameter tuning technique. Hyperparameter tuning technique. Tuning. There are two ways. The first one, grid search CV. The next one, randomizer search CV. Come on, I'm repeating again. Daniel, I just wanted to improve the model performance. I just wanted to improve what exactly? Model performance. If you wanted to improve the model performance, we already know few techniques. Along with that, one more technique you should aware. The first technique name is called as a train underscore test underscore split. Sorry. Train underscore test underscore split. Second technique name is called as a k-fold cross validation. We done both techniques. What is the third technique, sir? Hyperparameter tuning technique. What is the third one? Let me give a small little introduction, then we can move on with the next one actually. Right. Now let me start. Why this technique? Simple. To improve the model performance. To improve what exactly, sir? Model performance actually. Model performance, right? Now, Tim, whenever you're talking about the machine learning algorithm, having two types of parameters. Two types of what exactly? Parameters. The first one is called as a normal parameters. What is the first one? One more time. Normal parameter. Second one is called as a hyperparameters. Hyperparameter. The name itself is talking hyper. You can customize the values. You can provide your own values actually. I am repeating again. Take any algorithm. But let me talk about the few algorithms today. But if you take any algorithm having the two types of parameters, sir. One is normal parameter. It is also called as a default parameter. Cheptara? Default parameters. Default parameters. Imagine you apply default parameters, you may get a score something like a 85. But if you apply hyperparameters, let me tell you, your score will be boosting. I mean to say, I can give a guarantee something like a 92. Something like. Ultimately, why you are applying hyperparameters? Talk with me, sir. To improve. That's it. If no improve, then there is no, yeah, we need to improve the score, we need to improve the model performance. These are all things I mean to say. Team, are you getting or not, sir? I'm repeating again. Model having the two types of parameters, sir. One is the default, the next one will be hyper. If you apply hyper parameter, then you are improving the model performance. The score will be increased actually. What it will be increased? Best example, go to the random forest classifier, n underscore estimator. How many values we have given? 40. What is the default value? 100. The default is nothing but a default parameter. Default is nothing but what exactly? Default parameter. You customized the value, right? A kind of some 40 we have given. That is called as a hyper parameter. That is called as a, yeah, you are customizing the value. I can talk more actually. Are you clear or not, sir? Let me tell you. One more example I can take. One more example I can take. Imagine whenever you are running the machine learning algorithm, by default parameters, it will involve automatically. Automatically default parameters only involve. But you know, hyperparameters never involve automatically. Being a programmer, explicitly we need to trigger. Being a programmer, explicitly we need to trigger actually. We need to customize the value. I will show you practically, we'll get an idea. If you want, I will give one small example. The example will be, I still remember when I was in my schooling, I'm talking about 10th class. So I entered into the 10th class, sir. Entered into 10th class actually. 10th class. I hope you know a kind of some little tension to parents actually. Why? Because public exam. What exam? They will focus on, you know, the day, the first month onwards actually. Almost 3 months over. How many months over? 3 months over. It's a time for a progress card actually. Progress card time. Progress card time actually. The time for a progress card. Here is the story. My father has looked, my father have seen that progress card. On an average, I became like a average student. Out of 100, how much I am getting, sir? 35 to 36 I am getting actually. How much I am getting? 35 to 36. That is my default performance. That is my default performance. Then my father asked, why? If I believe you, 35 score actually, go to the public exam, then you may literally fail. I'm edge actually. Am I right or not, sir? I cannot say I can pass actually. Though in unable to perform in the unit test exams actually, right? Definitely in public I will fail. Then my father planning to apply hyper parameter. I'm repeating again, this is my default performance. I'm trying my side best actually. 1 hour I'm giving. 1 hour preparation I'm giving. That 1 hour is called as a default value. 1 hour is called as a. Then my father told, get ready on Monday, we'll go to one place actually. I asked why. Yeah, to improve your performance actually. Can you guess? Yeah, exactly, sir. Right. My father told, get ready, get ready, get ready. Monday, we'll go to one place. We'll go to what exactly, sir? One place, one place. Then I asked, where and why? So simple. I'm going to join, we are going to the tuition center. What center, sir? Tuition center. Why in the sense? To improve your studies. Chapman, sir, to improve your studies actually. Your studies. I joined, sir. Joined tuition center. Sir, 3 months. After 3 months actually. On an average 5 months. It's a progress card. What is the time? Progress card time actually. Sir, my father have seen the performance will be 60 out of 100. You talk with me what exactly happened. My father applied hyperparameter tuning technique. My father applied what? What happened if I apply hyperparameters? What happened? Yeah, performance increased actually. What do you mean by hyperparameter in terms of situation? Previously, I used to spend 1 hour only. Out of 1 hour, I'm not getting interest actually. I don't know. Maybe I'm deviating. But once I joined in tuition center, sir, morning 2 hours, evening 2 hours. Either you like or not actually. In a olden days, how the tuition center it will be, faculty, the tuition faculty, still I remember Sudhakar master. He will tell directly to the parents, if your son didn't study, I will beat first of all. That is agreement actually. My father will tell, come on, you can, you can beat actually. Sir, you can't remember. If the tuition center faculty is beating, I'm sorry for I'm getting laugh. Faculty, he will target one student. Remaining all students, they will separate automatically. I'm sorry, man. Can I get a response from you? Yeah. Chill would decide awesome, sir. ఒకళ్ళని కొట్టేటప్పుడు చూస్తే మిగిలిన వాళ్ళందరికీ ఆటోమేటిక్ భయం వచ్చేస్తుంది. But nowadays, students are beating faculties. Am I right? Okay, fine, Daniel. Let us move on to the top. Yeah. Back to the session. While creating machine learning model, we always define two things. Get ready. So we know two things actually. First one is default parameter. Next one is, I'm sorry, hyperparameter. Model parameters are the ones that are internal part of model and their value is computed automatically. So simple, when I'm talking about the model parameters, these are all computed automatically. You don't need to provide any external value. Today I'm going to explain SVM. I hope you already know. We worked with SVC. While we are creating, did you remember SVC? How you worked actually? Chappan sir, model equals to default parameter. Default parameter model equals to SVC. Did I provided any value? No. But today I will show you. Daniel, hyperparameter. What is that? Hyperparameter. What do you mean by that actually? Model equals to SVC of we are giving something here actually. I mean to say hyperparameters we are giving. Hyperparameters we are giving. Get ready to understand. మీకు అర్థమైంది లేదు సార్ మోడల్ ఈక్వల్స్ టు ఎస్విసి సార్ డిఫాల్ట్ పారామీటర్స్ వాట్ పారామీటర్స్ ఐ విల్ షో యూ బట్ hyper parameters in the sense what exactly no sir model equals to SVC of keyword arguments we can provide What you can provide? Another example, model equals to go for random forest classifier. What classifier? How much value you have given here actually? N underscore estimators equals to what exactly? Equals to 40. We can just have to come here. Model equals to random forest. Yeah. Default parameter. What is the default value? 100. That's it. Make a note actually. I'm sure. Meeku ardham avutunda? Can I get a response from you? Come on, let's move on actually very quickly. Online team, what about you? Why hyperparameter? That's it. To improve the model performance. Hyperparameters are the ones that can manipulated by programmer. Yes, being a programmer, we need to be take responsible. Daniel, why? To improve the performance of the model, like a learning rate actual. I will talk with you. Different parts of hyperparameter approaches. Now, conclusion of the story. Daniel, how to apply hyperparameter? Yeah. We understand what is hyperparameter. How to apply hyperparameters? There are two ways. We can apply by using two ways actually. The first one is called as a grade search CV. By looking at this one, you can guess one thing. What is that? Class. What is that one, sir? How can you say? Yep. Second one, randomizer search CV. Both we are going to see practically. First one is so called as a grid search CV. The next one is so called as a randomizer search CV. Can I continue? Yeah, simple. Let's move on. Little theory, get ready to understand. Hyperparameter, sir, can you read this word actually? Tuning. One more time. Go back to the gradient descent algorithm. The coefficients, it is slowly it is changing actually. What exactly? Slowly by slowly. Exactly the tuning meaning in the sense. Let me show you one small diagram. Yeah, tuning. It's not like a sudden change actually. Go back to the radio FM. Are we going to quickly we are changing actually? No, we may miss the station. Slowly, point by point we need to change it. That is called as a tuning. That is called as a tuning. Tuning in the sense, the progress is slow, but it is in progress. The values are slowly it is changing, but it is in what exactly is the progress actually. Yeah, little change which is going to impact actually. Hyperparameter tuning is the process of tuning the parameters while creating machine learning model. I already covered actually. Hyperparameter tuning is the process of tuning the parameters while creating the machine learning model. These parameters are defined by the programmer wish. Do you want it to change actually? Then you can go for this. Machine learning algorithms never learn these parameters. Machine learning algorithms never learn. Why? Because it is having the default parameters. It is having default parameters. If parameters are tuned, then we will get good performance. Yeah, that's what we are doing actually. And we can create the hyperparameter. We can define the hyperparameters as shown in the below. Think like a random forest classifier. These parameters are tuned randomly and the results are what exactly is checked. You can go for either random forest classifier or regressor actually. Did you remember what is this value, sir? 100. Default value is what exactly mean? 100 actually. Okay. We'll learn, sir. We'll see. We'll see while working actually. While working, maybe today itself only. Today itself only, we'll see. So practically, I can explain. You will get an idea. You in the sense everyone actually. Then what parameters ML model it will learn actually. I will show you. You will get an idea. Come on, make a note on this one. Tim, whenever you are creating an object for the random forest classifier, You know only one parameter. What is that parameter? N underscore estimator. Not only this, would you have other parameters? Bootstrap, alpha value, criterion, max depth, max feature. Daniel, is it important? Not much important. But let me tell you, these are all default values. These are all. Then can you tell me what is the value? 0.0 default value. If you want, you can increase 0.1. And the MSC is the default value. What is MSC? Cost function. Talk with me. Cost function actually. Are we covered? We covered actually. Please. That's what actually. But anyway, all parameters are not important, but N underscore estimators is important actually. Exactly, sir. These are all default parameters. Instead of 100, if you are changing to 60, that is called as a hyperparameter. Come on, I am repeating again. I am repeating, please focus on everybody. Sir, these are all default parameters. Cheptara, what parameter? Default parameter. But instead of 100, if you are giving 60, now this N underscore estimator is called as a hyperparameter. N underscore estimator is called as what exactly? Why? You are changing the default value. You are changing. That's what you need to understand. Right? Daniel, do I need to remember these are all? No, not at all required. Only the important parameters you need to be remembered actually. All right, Irish dataset we are going to take. Sir, it's okay, ignore the dataset. But over the same problem, we are going to solve, we are going to apply logistic regression, we are going to apply SVM, decision tree, random forest, naive Bayes. Above problem we can solve by using different algorithm. By using what exactly? Different algorithm. Now, if you're trying to use SVM, then it is having the different parameter. Quite interesting. By this time, you already know about the SVM. But let me tell you, for SVM, there are some different parameters. Let me show you. Hyperparameters tuning. The process of choosing the parameters is called as a hyperparameter tuning. Team, look at my screen. Example equals to model equals to svm.svc. Yeah, make a note on this one. These are all values you can change actually. Previously, SVC, empty parenthesis. But today, SVC of 3 values you can provide. What is the first one? You know, sir, chaptara 3 keyword arguments. First one is a kernel value. Second one is C value. Third one is gamma value. When it comes to kernel, these are all values you can pass. RBF you can pass, linear you can pass, polynomial you can pass. I will talk with you what these are all. C value, a kind of some integer you can pass. Gamma value, a floating value you can pass. Otherwise, automatically it can take some other value actually. I have a discussion with you today. Can you tell me what is the topic name? Hyperparameter tuning technique. If you are not passing anything, default it will get few values actually. But if you wanted to customize, today let me do this practice. Online team, what about you, sir? Are you getting everyone? I need one response from anyone. I just need one response from anyone of you. Can you talk with me, online team? Nageswara Sarji, thank you. Viswateja Reddy sir. Srinath. Okay, fine then. Let's continue. Daniel, can you tell me what do you mean by kernel here? Kernel. What do you mean by kernel? Simple man. It's a kind of some mathematical function actually. SVM algorithm use a set of math functions that are defined as a kernel. The function of kernel is to take the data as the input and transform it to what exactly is a required form. For example, linear, non-linear, polynomial. These are all kind of some kernel functions actually. So simple. If there is a non-linearity, if you are using these functions, it can bring into the linearity. It can bring into what exactly mean? Linearity. That's what you need to be understand. Okay. Team, we are entering into the discussion. Get ready. It is quite interesting example. You have to be understand. Are you ready, sir? Yeah, good. To understand this, you should know k-fold cross validation. Are you done practice k-fold cross validation? Okay. Hyperparameters. Yeah. These are all things we are using, sir. These are all things we are using. Now we can just have to come here. Iris problem statement. I kind of some iris data set actually, data set. These are all ways we are going to apply. What is the first way? Any idea? Train underscore, test underscore, split. Let us apply. Only one time training. Only one time training. The next one will be k-fold cross validation. Yeah, n times, k times actually. The third one is what exactly, sir? Hyperparameters. Hyperparameter tuning technique. I'm sorry, sir. Using grid search CV. First of all, be clear. We are going to take iris data set. Multiple algorithms you are going to take. What is the first approach? Train, test, split. Second approach, k-fold cross validation. We already know. We already know k-fold cross validation actually. Am I right or not, sir? Right. Then let's move on. We'll get an idea. Maybe I hope this is nothing. We need to load the data set. These are all things actually. I will start the cinema from here. What is the first approach, sir? Train underscore, test underscore, split. Okay. Let us take this point. You can make a note on this. Understand, sir? Any idea what is the topic we are doing? Importing the libraries and loading the data set, data preparation we are doing. Do I need to focus more? Not required. Directly go to the point actually. Train underscore test underscore split. And yeah, make a note on this one. Can you talk with me? SVC. What is the topic name, sir? SVC. Kernel equals to RBF. And what is the C value? 30. And can I tell you, here we are applying hyperparameters. Here we are applying what exactly? Hyperparameters actually. Make a note on this one. If you are not passing this one, default values, it will be triggered, sir. It will be trigger what exactly? Default values. I mean to say hyperparameter tuning technique we are applying by using train underscore test underscore split actually. Okay. Yeah, come on, let's apply. You will get an idea. Let's go for data preparation. Can we run once so that you can confirm? We are planning to applying hyperparameter tuning technique with train underscore test underscore split. I will tell you the limitation. I will tell you the limitation. Hold on. As usual, now splitting the data are we doing actually? Yeah, Daniel. Step number 4, splitting the data. What is the ratio, sir? Team, literally this step is not at all required. Why? Because directly we are using here actually, then there is no use, sir. Anil, why you have done? Just for showcase. Something went wrong, line number 36. Why? Yeah, very good. Siddiq Sarji, another 3 to 4. Let's move on. Sir, I need your help actually. I just need your help. Step number 5. Come on, very quickly. Model. Very good. Model creation. I'm sure you already know. We are creating the model. Previously, model equals to SVC we have created. But even today, maybe we are importing SVCM. From SVM, we have to import actually. That is still okay. From SVM to SVC. Previously, we done this step, sir. Default parameter. What parameter? But I don't want default. I wanted to apply hyperparameter. I wanted to apply explicitly. We need to call kernel equals to RBF, C value, auto. These are all things we need to call. Now please make a note on this one. What is the kernel value? RBF. What is the C value? 30. What is the gamma value? Auto. Step number 6 is so called as a model. Check the score. Team. One time I am running. That is okay. Let me run one more time. Let me run one more time. I know we are getting different scores actually. First reason why, any idea? Yeah, random underscore state we didn't apply actually, right? Are you clear or not, sir? Right. But anyway, on an average, we can take like, 93 is the score actually. Now let's take this example. This one is a score. Yes, see, I'm running one time, two time, three times actually. Make a note on this. Now the next step is what exactly, sir? Do you remember what is the next step? K-fold cross validation. Prediction, it's okay. Prediction, we already know that. We are checking the score levels actually. What is the next topic? This one is kind of some crucial step. You have to be clear actually, right? Now, maybe I can share today examples also. Can I create a demo too? Is it okay for you? Yeah, so that I can create and here take this step. And what is the topic name, sir? Chapter K-fold cross validation. So this one will be demo2.py. Yeah, good. Now I hope you already know this. Importing the libraries. The next one is called as a. Let us just have to take these are all. Any idea what is this? Function. Nice. I'm sure you know the process. You can just have to get this data, load the data set actually, loading the data set, data preparation. These are all copy. Same story. Apply here. Can you tell me what is the example? Demo 2. Let's run this just for confirm. Sir, now step number 4. Step number 4. Can you talk with me? Splitting the data set. Splitting what exactly, sir? Splitting the data set. What topic we are using? K-fold. K-fold we are using. K-fold cross-val. That is okay. Okay, Daniel. Then if you wanted to use K-fold cross-validation, you need to call the function. We need to call what exactly, sir? Function. Function. Yes, you are calling this function. I'm sure you already know. Function takes 4 parameters. P1, P2, P3, P4. Did you remember? What is the P1? Model. Then prepare the model. Here, step number 5, create the model actual. Model creation. I'm giving small hint. Who already done K-fold cross-validation, then only you will understand these are all examples. Otherwise, do little R&D actual. Do little practice on K-fold cross-validation, which we already covered actual. Okay. Now, yeah, Daniel, you can just have to create a model. Model create చేద్దాం చూడండి. SVC. Yeah, Daniel. చెప్తారా సార్? Model 1. That's okay. What is the P2? Input X. Yeah. Model 1. Okay. Then what is the P4? CV value. I hope you remembered. Thank you. Let's move on. And now these are all scores. These are what exactly meant? Scores actually. How many times model will run? How many times model will run? 5 times actually, right? Then how many scores you will get? 5 scores. Yeah. Can you tell me what is the first score? 100, 90, 96, 100 actual. Okay. Yeah. Make a note on this. I'm sure you know how to do these are all things, right? Are you ready, sir? Can you tell me what is the topic name? SV? One more time. SVC. Remember what is the kernel value? Linear. What is the C value? 10. Go to the next example. Tell me the difference actual. Kindly please observe what is the difference. Tell me. Yeah. Make a note on this one. Whenever you are working with K-fold cross-validation, manually you are changing the value. What are you doing? Manually. Come on, previously. Okay, understand the combination. Here is the combination you have to be understand, right? What is the combination? Yeah, we are applying this. First combination. Combination 1 actually. What combination? Model hyperparameters combination. Look at these are all value. Please make a note on this one. These are all parameters, sir. Kernel you are passing linear, C value, so and so value, and gamma value, so and so value actually. Then you will get a so and so score. Then check the score actually. Take this example, check the score. Okay. Now the same topic, understand the next combination. Next combination. Combination number 2. You help me, sir. What is the next combination? Kernel, what is the value? RBF. Okay, RBF actual. Instead of linear, what I need to pass here? Chappan, sir. RBF. Everything same actual, right? Now you can just have to go back here, pull those values actually. Manually, you are changing hyperparameters. Manually, RBF. Kernel function we have changed actually. Now check the score. Did I save it actually, sir? Rerun. Are you clear? You are getting some different scores. Okay. Get this example. You can just have to keep here. Now hold on. I have a question number 1. First combination. Talk with me. What is the value? Kernel value? Linear. In second, C value 100, gamma value auto. In combination number 2, what is the kernel value? RBF. C value is the 10, gamma value is the auto. Look at the next example. You tell me what is the difference actual. Tell me what is the difference. Talk with me. C value. First time we already run. Manually we changed, we run second time also. Third time, again we are changing. Again what exactly? Sir, like this, if you are keep on changing, C value 10 you can try, 40 you can try, 50 you can try, 60 you can try. This is also called as a permutations and combinations. What is that? It takes infinite times actually. Literally speaking, it takes lot of time. It takes what exactly, sir? If you are using k-fold cross-validation, to apply the hyperparameter technique, it takes lot of time. But if you are using grid search CV technique, what technique, sir? Only one time actually, it takes automatically all values. First of all, try to understand the existing limitation. Try to understand what exactly, sir? Existing limitation. Are you clear about this one? Team, I need one response from online team. Please understand this. I will repeat, sir. Please, I need focus actually. Again, C value how much actually? 20. You are getting different scores. Yeah, good. 96 and 100, again 90, 96 and 1. I'm sure scores are changing because of what exactly? I would like to say hyperparameters. What exactly, sir? Hyperparameter. Come on, let's take this example. Combination number 3. This one is a third combination. Third combination. Chappan sir, what is the value? 20. This is the code actually. Now you tell me what is the change here? Oh, great man. Now we are entering into the grid search CV. We are entering into what exactly? Grid search CV. I will give a small recap. Try to understand that small revision actually. Then I will enter into this discussion. Maybe today is not yet over. We'll see. Maybe if time permits, I can cover today itself only. We are applying hyperparameters. Hyperparameters actually. Hyperparameters. Tuning technique. Tuning technique. First way we tried actually. What is the first one? Train underscore test underscore split. Almost we run example 3 to 4 times we run actually, right? So run example, run 3 times. The code run 3 times and you will get a different scores. The next one, k-fold cross validation. Cross validation, sir, like a different combination. Combination 1, the next one will be combination 2, the next one will be combination 3. Like this, it will be keep on never-ending process actually. Never-ending process. What do you mean by first combination? You can go for linear, C value is the 100, auto value is the gamma value is the auto. Combination number 1. Combination number 2. You can go for RBF value. You can go for C value is the 10. These are all different combination. Lot of combination. Every time you change the value, run algorithm. Change the value, run algorithm. Change the value, run algorithm. Sir, it takes a lot of time, sir. Yeah, it takes a lot of time. But yeah, very good, sir. Instead of this one, if you are using, what is the topic name, sir? Grid search CV. Let me tell you, just one time only. I will show you within one time you will get the best score actually. Sir. Then what we need to do, Are you clear till now? I need one response from everybody. But Daniel, I didn't understand. If anyone is saying I didn't understand, then can I tell you? You are not done practice of k-fold cross validation. You are not done the practice of k-fold cross validation. Do little practice over this topic, then you will understand these all. Why should we use k-fold cross validation? Sir, I wanted to show you the difference. Whenever you are applying hyperparameter tuning technique, If you apply this one, what happened? I wanted to show you. If you apply this, what is the result? If you apply careful cross validation, then what might be the result? I wanted to showcase actually. Now, what is the advantage? You will get a clear picture. What is advantage? Especially, whenever you are using grid search CV, what is the advantage over careful cross validation? What is advantage over train underscore test underscore split? That's what you need to be understand. Siddiq sir, are you clear? Okay, so I'm continuing the session. Make a note on this. Did I copy the example, sir? Combination 3. This one is the third combination. I need to change actually. If you are a regular practitioner, you can understand. Let's move on. Siddiq Sarji, did you miss careful cross validation? Did you miss the day, that day? I mean, no, then you should aware actually. Let's move on to the discussion. Please, little practice, push your understanding actually. Okay. Yeah, sir, make a note on this. Previously, C value 10, we run algorithm. C value 20, we run algorithm. C value 30, every time we are changing. Instead of that, what we need to do, create a one dictionary. Wow. Create a one dictionary. You can configure all C values within a list. You can configure. You wanted to run algorithm with the C value 1, 10, 20, 30, 40. You can configure whatever value you want actual. Beautiful. What is the next value? Kernel. You can configure 2 kernels actual. Now what happened, sir? Algorithm is going to run 1 with RBF and linear, 10 with RBF and linear, 20 with RBF and linear. Almost how many combinations? 3 2 sir, how much actually? Chappan sir. 6 combinations it will run in one shot actually. But if you go back careful cross validation, manually, first time you need to run, second time you need to run, third time you need to run, sir, tedious process. It takes a lot of time. Okay. All right. So print this I can execute from scratch. Daniel, we're applying hyperparameter tuning technique. By using what? By using grid search CV. As usual, same steps actually. Importing the libraries. Loading the data set. Yeah, man, get ready. Then prepare a dictionary. To pass the grid search CV, prepare a dictionary actually. Talk with me, sir. D equals to C value we are configuring. Any idea? Dictionary. This one is called as a key, list of C values. This one is again new key, kernel, list of kernels actual. Daniel, can I give 40 50? Sir, up to you. This is really beautiful. Just one time only. You can configure and you can run actual. But how many times it will run in the backend, sir? The point will be C value it will take one, kernel RBF one time it will run. And you will get average score automatically. C value 1 and linear it will run another time actually. Like this 3 into 2. Total how many times? It will run automatically, sir. It will run automatically. That's the beauty actually. Okay. Let me show you how it is going to run. You will get an idea. Let me drink water online team. Wow. Man. So you need to use grid search CV. You need to use what exactly, sir? Grid search CV. Step number 4. Splitting the data set. Step number 5, model creation. One minute, 1 minute. I can talk, sir. I'm sorry. Special step. Planning to use grid search CV. Planning to use what exactly mean? Grid search CV. Daniel, how to use? Simple. Create an object. Kind of some obj equals to grid search CV. It takes some parameters. Make a note on this. What are all parameters, you know, sir? First parameter should be model. Okay. First parameter should be model. Second parameter would be, you can take the dictionary. Okay. Take the dictionary. Actually, this is seriously super. Right. And third parameter is, chaptara, CV value equals to 5. What is the value, sir? CV value equals to 5. Means how many times it will run in the backend? Like a careful cross validation only. And the next value, return train score false. This is optional parameter, but let us pass here. Grid search CV, the whole thing is nothing but creating an object, which is taking parameters, model you need to pass, dictionary. The total logic is available with the dictionary, frankly speaking. Are you with me or not, sir? Right? Why? Because here you can provide the different combos. Combination 1, combination 2, combination 3. This is really great actually. If this technique is not there, I use our manually we need to run many number of times. Many number of times. Think like that. Now written. This is not much important. You can still ignore that is still okay. Come on, sir. You are asking one question. What is that? Sir, it won't impact, sir. Gamma equals to auto by default. Because of this value, it is not impacting the score actually. Okay. Now let's move on. Finally, what we need to do is, by using this object name, we need to call a fit method. Not with model actually. Why? Because model you already configured inside this grid search CV. Now, I'm repeating again. Special step number 1, special step number 2. Please make a note on the obj.fit method. What method, sir? Fit method. Pass input and output actually. Pass what exactly, sir? Input and output. If you really understand till now, I'm sure, sir. Let me run actually. If you want, I will explain one more time. It is taking a lot of time. Good. So, I need to run demo 2. I need to run what exactly, sir? Demo 2 actually. Let us run demo 2. Yeah. Now here is the story. Whenever you are calling the fit method, yes, you know, the grid search CV object is ready. If you wanted to see the result, I'm sure you already know what is this. Any idea? Special attribute. Now all the result it is being storing in one attribute actually. You need to call that attribute. Then it returns dictionary, sir. It returns what exactly, man? Dictionary. A lot of values it is returning. You can just have to pass here. Yeah. Chapman, sir, what is object name? Object. For every iteration, you can see the results actually. Oh my God, lot of values we are getting. What we are getting, sir? Lot of values. Daniel, all these values are important. Look at the next example actually. You know, instead of this dictionary, by using the dictionary, any idea what I'm doing actually? Chapman, sir, we are creating a, come on, let's create actually. With the result, we are creating a data frame. Okay. Then print the data frame. Oh, thank you. I'm sorry. Demo 2. Wow. Seriously, very good. Sir, how many rows? 6 rows. How many columns? Let me tell you why 6 rows. Yeah, 6 combination. We'll do one thing. We'll do. You can just have to come here. Add one more 20, 40. Then how many combinations? 8. 4 into 2. What is the combination? Then here you will get how many actually? 8 rows. Come on, let's try. Yeah, average values. That's the beauty. Let me tell you, by default, it is applying careful cross validation because here we have taken what exactly, sir? CV value. What value we have taken? CV value actually, right? 1 minute, there is a one query from online team. Sir, can you please rephrase the combination provided by the dictionary? Yeah, sure, Sarji. Siddiq sir, please be focused actually. Let me explain one more time for your better understanding. For your better understanding, please focus. Go to the running notes. Siddiq sir, are you looking at my screen? Are you looking at my screen? Yeah, please be active. In first combination, whenever you are working with the careful cross validation, think like there is no grid search CV. Sir, manually, linear value, C value 100, we provided and we run algorithm, we got a score actually. See, kernel value linear, C value 10, gamma value is the auto. One time you run actually. If you wanted to change the values again, like a different combination, then what we need to do? We need to configure again these values. You can look at the example. Here you are configuring again, like a kernel equals to RBF and the C value is the 10. You wanted to change the values again. Then what we need to do? You can just have to come here and you are configuring the again new values. Every time this one is a manual process we are doing. Are you clear about this? Siddiq Sarji. Perfect. If you are clear about this one, Daniel, I don't want this manual. Sir, how many times we can do like this? 10, 20, 30, 40, 50, linear RBF, different combination. Instead of this, go for grid search CV. The beauty with the grid search CV, it takes dictionary. It takes, in dictionary, you can configure all combinations, what combinations you want actually. This is beautiful technique. Beautiful technique actually, right? 1 with RBF linear, that's okay. 10 with RBF linear, 20 with RBF linear. Daniel, like this, I wanted to give 500, give 1000 also. Up to you. This is something like one time we are configuring, algorithm takes care automatically. And it will run all combination. At last, it will give the best results. At last, it will give. If you go for careful cross validation, once you are running manually, pick the results actually. Result number 1, result number 2, result number 3. At last, you need to compare again actual. But in grid search CV, no need to compare, sir. It will tell which one is the best parameters automatically. Did you understand or not, sir? Right? Yeah, very good. Nice. Thank you. Thank you. Thank you. Which option is more used in real time, sir? Nageswara Sarji, good question. It would be good to validate these all things in real time. You can, best example, that's what I told. Machine learning is kind of some R&D process actually. You need to apply careful cross validation, and most preferable will be the grid search CV. Okay. Yeah. Team, let me tell you, this is not like a one time you may not understand. Look at that example, why I have written, why I'm executing. Slowly by slowly, you will get an idea. Are you with me? Good. Now, where are we? Siddiq Sarji, I need a response from you. Are you clear? I'm happy to explain one more time if you want actually. But yeah. Okay, sir. Fine there. Let's move on. Where are we? Daniel, we applied grid search CV, hyperparameter tuning technique. It takes model. Yes, model we prepared. The next one, taking dictionary. This is really powerful. And we are specifying CV value equals to 5 means with every combination, 5 times it is running, we are getting average score. Such a beautiful, sir. With every combination, it is running 5 times and it is giving average score. One shot, such a nice actual. Fine then. Obj.fit method we need to call. This is not model.fit method actually. Then, you are right, sir. You're right, actually. Right. If you wanted to see the result, you can call this attribute, predefined attribute. But this attribute giving the result as a, again, dictionary format. What format? But I don't want dictionary, sir. Data frame is seriously very good, actually. You can just have to get the data frame. Yes, this one is the result. We got it finally, actually. And that too, sir, 8 rows. Why? How many combination? Maybe I have taken here only 3. Let me rerun one more time. It takes little longer. Yeah, 6 combination. That too. Can you tell me what is the first column name? Mean fit time, STD fit time, mean score time. These are all not important, sir. All columns are not important actually. What is important columns, you know? These are important columns. What are all important columns? Parameter underscore C. I wanted to know C value. I wanted to know kernel value. I wanted to know mean score. This one is the, right table actually. But of course we are getting how many? How many columns we are getting? 15. All columns not important. I wanted to see C value, kernel value, mean score. Then you can just have to capture all these columns actually. Come on, chudani. You can capture these are all values. Is it okay? I can take here and I can just have to add this example. Wow, sir, talk with me. Parameter value 1, RBF combination. What is the score? 98. 1 with linear. What is the score? 98. 10 RBF 98. Almost top 3 is really great actually. Now here again, which one I need to select? Either 1 or RBF, 1 or linear. Again confusion. Don't confuse. There is one attribute. Call that attribute. That attribute name is a best parameters. What is that attribute? That attribute directly it will tell, go for C value is this, go for kernel is this actually. మీకు అర్థమైందా లేదా సార్? Right? Yeah, yes sir. Yes, sir. Data matters. Yeah. Can you talk with me? What is this one? Special attribute. What it is telling? Can you tell me? C value equals to 1, kernel equals to? That's okay. I mean to say what it is telling is directly. See, yeah, it is telling this is the best actual. Why? Because in first shot itself you are getting best score, right? You can go for this actual. Now these hyperparameters are good hyperparameters. What kernel value I need to configure? Nice. What C value I need to configure? That's it. Indirectly, we are using grid search CV to capture which parameters are best parameters. To capture what exactly? Once you understand best parameter, then you can configure and you can proceed actually. మీకు అర్థమైంది లేదా సార్? Right? I know it's take a little longer, but you need to do practice. These are all. Maybe tomorrow also I will cover the same thing. You will get an idea. Okay. Let me stop today. Once let's execute this example. But before coming for tomorrow session, do practice, then only you will get an idea. Until you practice, you cannot understand. Please. మీకు ప్రాక్టీస్ చేస్తేనే మీకు అర్థం అవుతుంది, లేదు అంటే థ్యాంక్ యూ. ప్లీజ్ యూ కెన్ స్టార్ట్, లెట్ యూ గో. And I takes care about uploading material. These are all stuff. Thank you, online team and offline team. Please take care. ఒక నిమిషం సార్. Online team, thank you for joining.